Section 4.6b is about function values. It's a new way of writing equations. Function notation is a way of writing equations that are functions. Here you see an equation. It turns out this equation is linear, it makes a line, and it's also a function. So if it is, we can write it this way in function notation. Now I want you to understand that this is not f times x. It's not. It looks like it is based on what we've done in the past, but this is a special way of writing something. Let's break it down. Here the x represents the domain. So whenever you see an x value, it represents your domain values. Now this f with parentheses and an x, that represents the range. It's another way of writing the y value. And the way that you read this is you read it as f of x. That's how you read that, f of x. So really, this letter f is just the name of the function. You can change that letter to anything. You can make it a G or an H or a P or a K. It doesn't matter. It's the name of the function. This function is called f, and the domain value is x. So f of x is all the numbers that represent the range value. So what we're going to do is we're going to do something like this. We're going to find f of 5. So what you do is you take f of 5 and you use the same function. You use your 3x minus 8, but instead of an x, you're going to substitute in its place a 5. I should make this blue too, that way you'll see the substitution. So since f of x is 3x minus 8, f of 5 is 3 times 5 minus 8. 3 times 5 is 15, and 15 minus 8 is 7. So we would say that f of 5 equals 7. Now what does that mean? That means I plug in a domain of x, and if you wanted to write it as an ordered pair, you can. And when I plug it in and do all the algebra, I get out a value of 7. That's my range. My range is 7. So plugging in a 5, getting out a 7. That's how a function works. And this is another way that you can write functions. Here we're going to do multiple examples using this function just so you can practice the algebra. We're told the function f of x equals 2x plus 5. So what is f of negative 2? Well, f of negative 2 says instead of an x value, I'm going to replace all the x's with negative 2's. So instead of 2x plus 5, I'm going to use 2 times negative 2 plus 5. Notice instead of an x, I put negative 2's in place of all those, and then I do the algebra. 2 times negative 2 is negative 4. Negative 4 plus 5 is 1. So we can say that f of negative 2 equals 1. I plug in a negative 2, I get out an answer of a 1. Next one, f of 1 plus 4. Well, f of 1, notice the 1's in parentheses and the plus 4 is not. That means you're going to take your function, 2 times x plus 5, and replace the x with a 1. But then you're going to tack a plus 4 on the end. And maybe I'll even put a circle around that to show you that that plus 4 comes at the end of our function. F of 1 represents all this stuff. My function 2x plus 5 with a 1 put in its place. So now do algebra. 2 times 1 is 2, plus 5 plus 4. That's 7 plus 4, which is 11. So f of 1 plus 4 equals 11. When I plug a 1 in, I get an 11 out. The last one, f of x plus 3. Looks different than the other ones because it doesn't just have a number, but we do exactly the same thing. Instead of an x, I plug exactly what's in the parentheses. So I put x plus 3 in that place, and now do algebra. I'm going to have to distribute the 2 here. So 2x plus 6 plus 5, and those are like terms that are on the same side. Plus 6 plus 5 is plus 11. So 2x plus 11, and that's what f of x plus 3 is. Here we have another function. This time notice the function is named g. So we would say this function is g of x, and g of x is 3x minus 4. But it doesn't change what we do. Whatever's in the parentheses goes in place of the x after the equal sign. So down here I'm looking for g of 4. I'm going to use colors here just because I feel it might help you. So g of 4 equals 3 times, instead of x, I'm going to put the 4 in. So can you see that substitution? G of 4 means I plug in 4 in for the x. 3 times 4 is 12. 12 minus 4 is 8. So we say that g of 4 equals 8. I plug a 4 in, do the algebra, and I get an 8 out. Now we're going to do g of negative 5. Again, we'll use colors to help you if you haven't figured this out yet. My g function is 3x minus 4, but instead of an x, I've decided to substitute in a negative 5. Now we do algebra. Negative 15 minus 4, that's negative 19. So g of negative 5 is negative 19. I plug a negative 5 in for x, and I get out a negative 19. Over here, g of 2 minus x. Stick with the color. Instead of an x, I put whatever's in the parentheses in for x. So now I'm going to put a 2 minus x in that parenthesis, and then do some algebra. You'll notice the distributive property has to work here. 3 times 2 is 6. 3 times negative x is negative 3x minus 4. I see like terms that are on the same side. And 6 minus 4 is 2, so we get negative 3x plus 2. And that's what g of 2 minus x is. Here's an example of using a function, but this time the function's not linear. It has a square on it, which you can't square a variable if you're going to have a linear function. But that's okay. We still do exactly the same thing, this time with a little more complicated equation. So h of negative 4, I'm going to plug in my negative 4. And this time, I want you to notice the difference. I don't have the letter x, I have the letter z. Well, that doesn't matter. That just means z is my domain letter. And whatever I see in the parentheses, I plug in place of the z. So here, negative 4 goes in for the z. That's another z, so I plug negative 4 in for that, minus 4, and I do algebra. Negative 4 squared is 16. 3 times negative 4 is negative 12. 16 minus 12 is 4, and 4 minus 4 is 0. So it turns out that h of negative 4 is a 0. When I plug a negative 4 into this equation, I get a 0. Now h of 5a, don't be shaken by the other letter there. Don't worry about that. Just in place of the z, you're going to put 5a. So instead of z squared, I put 5a squared. Instead of 3z, I put 3 times 5a, and then minus 4. And then do whatever algebra you can do. When you square 5a, you get 25a squared. 3 times 5a is 15a, and then minus 4. None of those are like terms, so that's as simple as I can get it. I end up with a trinomial. This is why this one's a little more complicated, but the procedure is still the same. Here, 2 times h of g. So what does that mean? That means take the g and plug it in for the z in the h function. Let me say that again. Take the letter g and substitute it in place of the domain, in for my z. So instead of z squared, I'll use g squared plus 3g minus 4. But don't forget that all of that is being multiplied by the number 2. So I'm going to distribute that number 2 to 3 different terms. 2g squared plus 6g looks like minus 8. And that's what 2 times h of g equals.